a two-digit number is such that the product of its digits is 6. When 9 is added to this number, the digits interchange their places. Find the number. All right. Now we've got a two-digit number, so obviously it's got two digits. So we have a tens digit, right, and a units digit, right. And now suppose, for example, if I have a number like 47, right. So 4 and 7 are the two digits of the number 47. So now these digits are what are the unknowns in the question. And since there are two digits, let's assume two variables to start in the question. So I can say let uh, the tens digit be x, and units digit be y. Right? Let's take the two variables as x and y. The tens digit is x, the units digit is y. Now realize one thing. If 4 and 7 are the digits, 4 is a tens digit and 7 is a units digit, I could write this number 47 as 10 into 4 plus 7, right? Because it's in the tens place, so 10 into 4. Now if I have x and y, x in the tens place and y in the units place, the number becomes 10x plus y, right? So these are the digits and this here is my number. So the tens digit is x, units digit is y, therefore the number that we need to find, right? The number, or rather let's call it the required number. The required number is equal to 10x plus y. 10x plus y, right? Because that's the number, right? Tens place, x is in the tens place and y is in the units place. Now, what are the conditions given to find these values of x and y? So the product of its digits is 6. That's the first thing that we know. The product of its digits is 6. So product means multiplication. So if I have to say that, therefore, now rather since product of its digits is equal to 6. This implies product of its digits is x into y. So x into y is nothing but xy is equal to 6. So this could be considered as my first equation. All right. Now there's another condition given to us here. When 9 is added to this number, the digits interchange their places. All right. Now think about this. So x is in the tens place, y is in the units place, and when I add 9 to this given number, which is 10x plus y, the digits interchange. So I end up getting y in the tens place and x in the units place. And in this situation, the new number that will be is 10y plus x, right? So this is what we want to do here. Now when 9 is added to this number, so 9 added to the number, right? 9 added to the number, to the required number, required number, the digits interchange this place. So that's basically the reversed number, right? The digits are interchanged, the number gets reversed. So 47 becomes 74 basically. So 9 added to the required number. Now understand our required number is 10x plus y. The digits are x and y. The number is 10x plus y. So 9 added to it. So it becomes 10x plus y plus 9. 9 added to it. And is equal to the reverse number. The reverse number is, as we were discussing earlier, 10y plus x. So 10y plus x. Okay, let's rearrange this equation. Because understand we have two unknowns here and we are getting two equations, but we want to substitute one in the other to get a quadratic in one. So if I was to rearrange this equation, let's keep the x on the left hand side and the y on the right hand side. So if I was to do that, taking this, so you have 10x over here, right? Plus x from here comes to this side, becomes minus x. This side I have 10y minus y and minus 9, bring everything. So this side here, 10x minus x is 9x, which is equal to 9y minus 9. All our 9's over here, let's divide this entire equation by 9, right? Divided by 9. So this gives me the value. I can say therefore x is equal to y minus 1. Okay, so let's consider this to be my second equation. Right. Now, the way we can proceed further from here is by substituting equation number 2 in equation number 1. Right. So by substituting equation substituting equation number 2 in equation number 1. Okay, what does that give us? Now instead of x, I'll write y minus 1. So I have y minus 1 into y, which was already there from before, which is equal to 6. And this is what we, substituting 2 in 1, we get y minus 1 into y is equal to 6. So let's expand this equation. Y minus 1 into y will give me y square minus y is equal to 6. Rearranging this further, this is here we just applied the distributive property. Now we'll bring this 6 from the right hand side to the left hand side, and we get our quadratic equation, which is y square minus y minus 6 equal to 0. Right? So this is our quadratic equation, which we need to solve by splitting the middle term. Right? And if you see now, the product that we require is 1 into minus 6, which is equal to negative 6, and the sum of the two factors. Two numbers multiplied should give me minus 6, and when you add them, they should give you minus 1. Right? So two numbers are minus 3 and 2. Minus 3 into 2 will give me minus 6. Minus 3 plus 2 will give me minus 1. So this is how we can split our middle term over here. Right, so let's do just that. So therefore, y square minus 3y plus 2y minus 6 is equal to 0. Right, now if I am to factorize the terms, so between the first two terms, if you notice, we have a y which is common, right, and in the bracket I'll be left with the y minus 3. Between the second and the third, between the third and the fourth, there is a plus 2 which is common, and I'll be left with a y minus 3 in the bracket again. So this is equal to 0. Okay. Factorizing this further, y minus 3 can be taken out as common, so I have y minus 3 into y plus 2, all of this together equal to 0. Now finally, the zero product rule. Two numbers multiplied gives me 0, so either y minus 3 must be equal to 0, or y plus 2 should be equal to 0. On solving the first equation, I get the value of y should be equal to 3, or if I solve the second, I get the value of y should be equal to minus 2. Okay, now what is y? What are x and y over here? If you notice, x and y are nothing but just the digits in the number, right? Now the digits in a number can never be negative, so y minus 2 will need to be rejected. Yeah? So we can say digits cannot be negative, right? Therefore, y is equal to minus 2 is rejected. Right. So if y is equal to minus 2 is rejected, that leaves us with the answer for y. Therefore, I can say y is equal to 3. And we also need to find the value of x, which we can do by solving equation number 2. X is equal to y minus 1. Right? And x is equal to y minus 1, which is equal to 3 minus 1, which is equal to 2. So we found the value of x and y, but that is not the final answer. The question that was asked was to find what is the number, and the number is, remember, 10x plus y. So all you need to do, or or you can think of it as the tens digit to be x and the units digit to be y, so the number becomes 23. Right? So either you can solve 10x plus y to get your final answer, or we can directly say, therefore, the required number, right? Remember, x is the tens digit and y is the units digit, so the required number is 23, the tens digit and the units digit. This is our final answer, which we will put in a rectangle.